Hello people, welcome to module 10 of Basics of Engine Mechanics. In this module, we'll be learning how to describe the conditions for two systems to be equivalent systems, and we'll solve a problem to find an equivalent system. Okay, so let's start. So for two systems to be an equivalent system, the sum of forces acting on body 1 should be equal to the sum of forces acting on body 2. That is the first condition. And the sum of moments about a particular point P, which is common to both system 1 and system 2, should be equal to sum of moments about that same particular point P about system 2. Okay, so this is the condition for two systems to be an equivalent system. Okay, so this is an example I have taken, and we have to find out an equivalent system at point C. This is the point C, suppose we define. Okay, this point, and this is point A, and this is point B. So what first condition is summation of, then we first of all we draw a system 2. Okay, and this is the C point, this is system number 2, this is system number 1. Okay, so summation of forces on 1 equal to summation of forces on system 2. So on 1 we see there is a force of 200 newtons in I direction and 350 newtons in J direction. That will be equal to 200 I plus 350 J will be equal to sum of forces in second system. So at point C we can draw a force of 200 in I direction and 350 in J direction. So that is the fulfillment of the first condition. Okay, so this is again what I have drawn. Now the second condition is we have to have some balance of moments. So the moments balance on system 1 about a particular point C should be equal to the sum of moments at a particular point C on system 2. So suppose this is point A and B. So if we take the moment about point C using these two forces, the force is, this is the position vector, suppose R, C, and this is A and B. A suppose using, so sum of moment about this on this system 1 which should be RCA cross the force vector, and that should be equal to sum of the moment in system 2. So RCA is, if you recall in past modules, you will be able to do this very fast. RCA is you have to move 7 units in I direction and 2 units in J direction. So 7I plus 2J crossed with the force which is 200I plus 350J. Okay, so this is the thing what we require this time, and we will find the cross product about this one. So that will be equal to 350 times 7, that is equal to 2450. Okay, 2450, and I cross J is K direction, and again J cross I is minus K, so minus 2 times 200, that is 400 K. Okay, and we already have a moment of 100 Newton meters. If you see, that is a clockwise direction, that means negative Z, that is again minus 100 K. So that gives us 1950 Newton meters of the moment about this point C. Okay, so that can be, that is again I have shown here in this system number 2. If you want, additionally you can find this resultant of these two forces, which is 200I plus 350J, that will be equal to, the magnitude will be equal to square of 200 square plus 350 square, that will be equal to 403. And so you can simply write it here as this force is of magnitude 403, which is over, it should be over at the slope of 3.5 over 2, because 350 over 200 is the tan theta, so theta will be tan inverse 3.5 over 2. So this is the final answer you will be getting, and this is the equivalent system.